I am a science journalist who has just written SUPERHEAVY, the first pop science history of creating elements and why this is breaking the periodic table. I've visited every lab that's involved and know the teams currently racing to create the next elements. IAmA. My short bio. I'm Kit Chapman, science journalist formerly with the Royal Society of Chemistry. For the past 3 years I've specialized in superheavy elements, elements so unstable they do not exist on Earth. I've met every team that's discovered an element since 1940, and visited Lawrence Berkeley, Lawrence Livermore and Oak Ridge National Labs in the US, GSI Darmstadt in Germany, the University of Stockholm and Chalmers Institute of Technology in Sweden, Dubna, Russia, Riken, Japan, and Australian National University, Australia. Ask me anything about the weird history of element making, including how Superman and Cole Sanders got involved, how we make elements, or where we're going to end up going. SUPERHEAVY is out in select bookshops and at Cheltenham Science Festival and Stoke Newington Literary Festival now. You can also order it online. Here my proof. Twitter previous IAmA.
Doesn't 27 says what exactly do you mean by this is breaking the periodic table?
Chapman replies the periodic table is based on rules, one of which is periodicity, that a group follows a certain pattern. So lithium fizzes in water, sodium burns, potassium explodes. Only the superheavy elements break those rules. They are so large we start getting something called relativistic effects, and that alters how the elements behave. So oganesson should be an unreactive gas with filled electron shells. It's probably a reactive solid with no electron shells. Everything just forms this electron soup called a Fermi gas. As soon as you get to the superheavy elements, the periodic table just stops working. And that's really exciting.
Marla Shannon says what drives you to want to create new elements?
Chapman replies it depends. At the start it was the race to build the atomic bomb. The first two passed uranium, neptunium and plutonium, were kept secret for this reason. So much so the work was done in a tiny attic space in Berkeley, California. The attic stank, which is why plutonium is poo rather than PL. Get it? When it moved into the Cold War, nobody was really sure what use the elements would be, but gradually it shifted to national prestige. The US and USSR both competed with each other for the honor of making the elements first and naming them. This was also one of the main motivations for the Japanese team. They wanted an element named after Japan. Today it's about pure research. These elements are rewriting our knowledge of chemistry and the universe in general, so it's pure scientific exploration. Retrend says, will the new elements ever be used by us? Chapman replies some are. Plutonium for example in nuclear reactors, americium is used in smoke detectors, californium is used in the Mars rover, but the really heavy ones? At the moment it's hard to say. If they remain as unstable as they are, it's doubtful. They are too short-lived to be of any practical use, or even to see them. Some last 10,000ths of a second. However, if we can hit the island of stability, a region we believe exists where these elements are more stable, then we could in theory use them realistically though. At the moment their main use is understanding how the universe is put together, which is still pretty cool. Ratatatail says, any thoughts on the island of stability? Chapman replies it exists. The challenge is getting there. We don't have enough neutrons at the moment, but there are a few good ideas about how we could hit it. We might also have an island around 120, which could be interesting to see.
Das Auto 7 says, how close are we to creating element 119? Could we see that discovery in the next 5 years?
Chapman replies, so close. 2 teams are working on it right now, the Russian US team and the Japanese. The Japanese have sworn to keep going until they find it. It's a real race. We're almost certainly going to see the first atoms in the next few years. It's unlikely the discovery will be official for at least a decade, though, as it would need to be confirmed etc.
Says, any favorite element and why?
Chapman replies it varies day to day. I've said boron in the past, because it's so odd, and I love looking at bismuth. All the shiny, but I would have to go with oganesson. I know Yuri Oganesson, and how many people can say they know a person a chemical element is named after?
Lulu Rose says, what's one of the most interesting fact about this field you're studying?
Chapman replies, we wouldn't have KFC if it wasn't for the Manhattan Project. The scale-up for plutonium was worked out at the world's first permanent reactor at a secret base in Tennessee called Oak Ridge. and the assistant cafeteria manager for Oak Ridge, Harland Sanders. Afterwards he set up Kentucky Fried Chicken. If you want a science fact, one of the labs separates its plutonium using an anal vibrator. It's easy to clean, has exactly the right RPM and is cheap to replace. Also it can be used for up to 45 minutes continuously.
Radial Velocity says, wow, that actually looks like a fascinating book about a field of scientific history that I know very little bit. I've heard of the superheavy elements of course, but not the stories behind them and what it all means for chemistry. Just curious, what was one of the big ways you would say that a superheavy element has changed our understanding of chemistry?
Chapman replies, the greatest example is rearranging the periodic table. When we created neptunium and plutonium, everyone assumed that they belonged in the main body of the periodic table, so uranium was under tungsten, rather than separate like the lanthanides. As we made more of them, we discovered that everything we thought of was wrong. We had a whole new series, which we called the actinides. Another great example is how flerovium behaves. It should be a homologue of lead. It's under lead in the periodic table, but, actually, it's more like mercury. What? And, of course, we wouldn't have our space probes without these elements. Voyager, Mars rovers etc. all depend on these elements to work. So we learn tons. It's a huge prize in science.
Zmenace23 says, could any of these created elements already exist in nature?
Chapman replies, yes. In space, almost certainly. Probably when neutron stars collide or a sun goes supernova. On Earth, we think flerovium, element 114, might exist naturally on Earth somewhere. We've been looking since the 1970s. From the San Francisco BART network to stained glass windows in churches to brine shrimp in the Indian Ocean. So far, no luck. The heaviest we have found that was here since the Earth's formation is a small amount of plutonium.
Hank the Tank says, somewhat related topic. What advice do you have to someone currently graduating with an MS in biochem that is highly interested in science journalism but doesn't necessarily have a lot of experience?
Chapman replies, experience is important, even at the beginning. To start by trying to build a portfolio, you've got a few options. There are C-Com postgrad courses or internships, and of course your own student paper, but you need to start writing. Pitch to some of the magazines to see if you can do something. There's a host of opportunities for young writers. Start doing investigations. Anyone can use the Freedom of Information Act to find out something. Look at people who could make an interesting profile piece and write about them. Get on Twitter and start networking. A lot of journalism is about who, not what. You know, most important of all, you're going to get rejections. Everyone does. Deep breath and try again.
Ilraso says, you have any hope for an island of stability past 120?
Chapman replies, Yuri Oganesyan feels there will be one around 120, and there are predictions there might be one after that. Much further beyond I think it's unlikely. Relativistic effects mean that the elements are going to get really funky and strange. Nuclei the shape of donuts. Elements without electrons. Just bare cations. So who knows?
Cyanide Hollow says, how do you determine which targets to bombard and what elements to use for bombardment?
Chapman replies, great question. On a basic level, you want to use something that adds up to the right number of protons. But with the technique being used at the moment, something called hot fusion, you also want a lot of extra neutrons. These neutrons are cast off during the fusion reaction, helping to stabilize the nucleus and preventing it from exploding. There aren't many light elements that have loads of extra neutrons, but one that is easily available is calcium-48, 20 protons, 28 neutrons. This is also something called doubly magic, which is a big advantage. So, now you know you're using calcium, 20 protons. You choose your target depending on what you want to make. For example, if you want tennessine, 117, you need to shoot calcium into berkelium. Element 97, we can't use calcium to make elements beyond 118 because past element 98 there isn't enough material of any of the elements to make a viable target. So we're now using slightly different reactions.
Marla Shannon says, where might these discoveries take us?
Chapman replies, that's the really cool thing. We don't know. At the moment, it looks like Oganesyan, the heaviest element we've found, doesn't behave as it should. Oganesyan, if you look at a periodic table, is in the noble gases, the same group as helium, neon and argon. It should be an unreactive gas, but we think it's a reactive solid. All the rules stop applying the heavier we go. It also lets us model the universe far better. At the moment the fastest computer in the world can only model a supernova to about the creation of lead. Much more than that and it's too much computing power to manage. But we can create another 36 elements in the lab, so we can do very basic experiments and learn much more about how our universe is constructed.
Harry Truman says this is one of the most interesting IAMAs I've ever seen. Thanks for giving us a glimpse at your personal fascination with elements. I don't really have anything to add, but I'm curious about your thoughts on a few simple things. 1. How did you cultivate your knowledge of chemistry, and how did you become such a skilled writer, speaker and educator? Somewhat ancillary, was there ever a tipping point where you suddenly knew you wanted to learn everything you could about elements? 2. What, if any, citizen science can be done around enabling laymen to be involved in any way? 3. Your username, /u/Mr. Kit Chapman. Why second C instead of a K? Thanks again.
Chapman replies 1. Practice. I've been writing about science for 13 years. I became interested in these elements when the last 4 got their names. It captured my imagination for a few reasons, one of which was that there was a petition to name an element after Lemmy from Motorhead 2. There's not really any citizen science in this area because it's both expensive and very dangerous if you don't know what you're doing. Hey, we're dealing with nuclear material in a vacuum tube. Point 3. You know, I have no idea. Everyone assumes the MRC stands for Mr. Kit Chapman, which I guess is an easy mistake. It doesn't, although I can't remember what the hell it does stand for when I made this account.
Memphis Peace says great thread. I know jack shit about chemistry but the periodic table has always fascinated me. Why is it so damn beautiful? It's like looking at a Picasso or something. Seriously, why is it so beautiful to look at? Or is it just me?
Chapman replies the shape of the periodic table is, to a scientist, elegant in its simplicity. You could have arranged it in many ways, and many people do. Here's a whole feature on different shapes, but the classic version gives you everything you need at a glance. It's ordered in proton number, but from left to right you can see the electron configurations. Looking down you can see groups and how similar elements behave. You can tell if something is a metal, understand how our building blocks of the universe relate to each other, and, at the bottom, away on a naughty step, we have the lanthanides and actinides, outcasts that are fascinating to understand. The names are evocative, the symbols hint as a mystery that you can understand with patience and study. It's a wonderful thing.
Thermonuclear Muskrat says what is the best type of monkey?
Chapman replies look behind you. A 3-headed monkey.
Recathetraveler says do any of the new elements being created behave like noble gases, extremely stable and non-reactive, and if they do, are the noble gas elements longer lasting and safer to use in a variety of products?
Chapman replies so far, no, they aren't behaving that way. That's why there's a lot of interest around oganesson, which is supposed to be a noble gas but almost certainly is not.
Marion Barbarian says is this book something that a common peasant with a passing interest in science would understand and find interesting, or do you need to have letters after your name?
Chapman replies it's for anyone who is interested in science. I assume no knowledge, and while the science is there it's really about the personal stories and some crazy, hilarious tales about things that went on during the Cold War.
BGJ38 says did you talk at all with Professor Sir Martin Polyakov who does the periodic table of videos on YouTube? He's a professor at University of Nottingham. Seems like a fun guy. I've been binging his videos lately.
Chapman replies yes, I've met Martin a few times. In fact I interviewed him a few months ago.
Kit Chapman says I was a member of one of the 3 or 4 research teams globally working on superheavy elements and was an author on a few papers including one that confirmed the discovery of a new element. I find it so funny this extremely niche area of science has managed to capture the public imagination and will be purchasing your book, mainly to see which of my former colleagues get a shout out. Did you manage to speak with Darlene Hoffman? In my opinion, she is a true national treasure.
Chapman replies, Darlene Hoffman is amazing. She's my heroine, battling through sexism from the 40s until today, missing out on Einsteinium and Fermium because they insisted a woman couldn't be a chemist and wouldn't let her in the lab, then going on to find plutonium in nature. I didn't speak to her, although I read her book. As you know, she's in her 90s and retired. I did speak to just about everyone else though. Mark and Nancy Stower, Ken Gregorich, Dawn Shaughnessy, the Oak Ridge team, the XE team, except Armbruster, Oganeshan and the Dubner team, Rickon, except Morita, and quite a few others you will know.
Rangared Rascal says, can a layperson read the book and understand it? I find this fascinating, but I don't have a background in science.
Chapman replies, you can. It's written assuming no knowledge. I try and lay things out as simply and clearly as possible, and the non-science stories are amazing, so it was a pleasure to write about them.
Still single says, if you had a say in 1990 when IUPAC adopted a spelling for our 13th element, what would you have gone with?
Chapman replies, I'm British. PMMEUR vagina yo says, I'm super tired, so sorry if I am missing something, but what is pop science history edit, and what do you think new elements could be useful for? Would there be any elements we don't already know of with half-lives of more than a second or so? Chapman replies, popular science history. Basically it's a bit of science, a bit of history, and it's written so you don't need a degree to understand it. Sorry if you were expecting an epic rap battle of Tesla versus Edison.
Edward M10 says, what do you think of Superhot?
Chapman replies, Superhot is the most innovative shooter I've played in years.
Bajak says, any advice in how to get into science journalism and communication? Sounds like a dream job, getting to meet interesting people and meet new people. You must love it.
Chapman replies, I do love it. Some days you are sitting down chatting with someone about Beyonce and you go, wait, this person has a Nobel Prize, and you wonder why they are talking to you. My advice is pretty simple. Get writing and get networking. You need to build a portfolio and make contacts. That way you can take your chances when they come.
IAM says, what is an element scientists are currently trying to create and why?
Chapman replies, currently they are trying to create elements 119 and 120. They are the next ones that we haven't discovered yet. But there's also loads of work going on to find different isotopes of known elements. This is really the most exciting work, as a new element is really only part of the equation. It's the isotopes that really teach us about the world and have possible applications. Currently the SUPERHEAVY element factory in Russia, just been built, is really going to ramp up that kind of work.
History at people say, as what's the Edison-Tesla rivalry in today's super-heavy element scene?
Chapman replies, it was Seaborg and Gyasso, the Americans versus Flerov and Oganeshan, the Russians. For 40 years the world had two different periodic tables, depending on whether you thought the Americans or Russians discovered things first. The end periodic table is, well, more or less a fudge between the two. Today there's no real aggressive rivals, and Oganeshan is the only one of the four still alive.
Skillsapper says, between all countries which one is the most aggressive participant in this race?
Chapman replies, in the early days, the US. They ordered fighter pilots to fly into nuclear mushroom clouds to gather up debris in the hope of making a new element. Today it's definitely Japan. They've got element fever. Their team is hardcore. They spent 9 years to see 3 atoms for their discovery of element 113, and they are bankrolled by the emperor himself. They want new elements badly.
Clean Reserve 4 says, since Asimov spent so much of his career writing about chemistry and physics, both for fiction stories and non-fiction, do you have any favorites of this author?
Chapman replies, probably Nightfall. It's a great conceit. Darkness for the first time, and the world goes bonkers.
Div2 says, I've been reading a lot of stories that deal with chemistry lately, which got me thinking of elements and chemical reactions. Anyways, I was looking into the creation of new elements, and it seems like all of them are trying to be created by colliding them in a particle accelerator, then trying to detect them before they disappear. I do realize that's how things are normally done, and it has worked in the past. But I was wondering if a different process could come up with a desired result. That instead of super accelerating molecules, if it was possible to supercool molecules to near absolute zero temperatures, and have them combine in that way to form a new element?
Chapman replies the problem is the combining part. To get over the inherent repulsion of the nucleus you really need to fire things together, and that means hot temperatures of a couple of 100 degrees.
Humped for Trump verified say how do you know if an element is created? They only exist for a couple microseconds. How do you know what the properties of the element are?
Chapman replies you look for radioactive decay. You know that elements decay through alpha radiation, so you set up your machine to look for that. That gets rid of 2 protons, 2 neutrons, turning into an element you know. So if you try and make 118, and you get readings for something, 116, 114, 112, then you know you've made 118 because of the decay chain. Another way is time of flight. You can basically measure the speed of things pinging about in the machine and work out its mass from there.
Monaco says hello. Have you visited? Have any thoughts about MSU's Freud?
Chapman replies I was just talking to Witek Nazariux the other day about it. Going there in September or October and I am really excited.
Say IAmA says you have any comments on Bob Lazar's claims of 115 stability?
Chapman replies
Irgfeflet says why has 119 been so much harder to achieve than 118?
Chapman replies we can't use calcium. This was used for the previous 5 elements, as one of its isotopes. Calcium-48 is great for making elements. The problem is that to make element 119, we would have to use a target made of instinium. There isn't enough instinium on Earth to make a target, so we can't use calcium, and titanium or vanadium. Beams just aren't as good at making elements.
The Real Extrusion says is this just a transparent attempt to drum up interest and sell your new book?
Chapman replies actually I want to talk about Rampart.